This is section 2.2, piecewise functions only. And so this first slide right here is showing an example, a real world example of a piecewise function. It tells us that Southeast Electric charges 9 cents per kilowatt hour for the first 200 kilowatts. And then after that, the company charges 11 cents per kilowatt hour. So notice that there's a change of that relationship between how many kilowatts are used and then the cost per kilowatt. And so that's what we're looking for in piecewise functions, is that a change occurs in that relationship between X and Y. Okay, a quick lesson in inequalities. So it tells us to use interval notation to express the solution set and graph the solution set on a number line. So when we were solving for inequalities, remember that it's exactly the same as solving an equation, except when we divide by a negative or multiply by a negative. But other than that, I'm going to go ahead and rewrite the inequality right here. 2x plus 4 is less than 10. Okay, just like I would in a regular equation, I'm going to start trying to isolate x. So I'm going to start undoing things on the side that there's x. Both my sides are simplified, so I can't do anything there. And then my left side, I'm like, okay, I'm going to get rid of that 4. Do it on the other side. I'm actually going to come up here. So now I have 2x is less than 6. I'm going to divide by 2. So then I get x is less than 3. Okay, so looking at my answer choices below, sometimes it's easier to do that before you answer what your solution set is in interval notation. So just keep that in mind. Now, of course, when you're in my math lab, sometimes they won't show the next part until you've answered like part 1 of a question. But even if you work that out on your paper, so think about it. If x is less than 3, that means that all the numbers, all the values below 3, less than 3, is my solution set, right? So A would not be an option because it's showing all the values greater than 3. And then B is an option because it has the highlighted portion of the number line of numbers less than 3. And then C looks like it could be an option too because all the numbers less than 3. But this is the difference between B and C. B, we see parentheses, and C, we see brackets, right? Let's go ahead and mark out D because it says the solution set is empty, and that's not true. We do have values that are less than 3. So I look at the parentheses versus the bracket. When we talk about parentheses, remember we're saying we're not including that number. We're just saying up to that number or beginning at that number, where brackets say yes, up to and including that number. Well, if x is less than 3, then we would not include the number 3, right? Because 3 is not less than 3. So my answer would be B. And the reason I chose B was because if I had, let me erase this line underneath here. If I had less than or equal to, then I would have went for the bracket because I'm including 3. But because it was just less than 3, then I'm using parentheses because I'm not including 3. Okay, so now let's look at filling in our solution set. Your solution set will model the number line. And like I said, sometimes even on a student's paper, I'll say, well, show me that on a number line, how that would look. And sometimes that clears it up for them when they're trying to answer their solution set. So going from left to right, looking at the number line on B, where would we start? Well, that arrow keeps going all the way back to negative infinity. So we'd have negative infinity up until 3. And then what do we have on that 3? Parentheses, because it's not including it. So if you find that you're struggling with answering the solution set in interval notation, I highly encourage you to try to express it out on a number line, even if it's like on a scratch sheet of paper, and then going from there. Let's look at the next one. Okay, we're using the interval notation to express the solution set and graph the solution set on a number line. All right, so I'm going to copy this down. Maybe I should have put it on the bottom. 4x minus 1 is greater than or equal to 7. Okay, both my sides are simplified, so I'll go ahead and move into trying to isolate that x on one side. I get 4x is greater than or equal to 8. Continue on with isolating that x. Divide both sides by 4, so I can have 1x. So just x is greater than or equal to 2. Okay, so x is greater than or equal to 2. Let's just talk about x is greater than 2. So if x is greater than 2, that's like numbers like 3, 4, 5, 6, 7, 8, right? So I can mark off A, mark off C. No, our solution set is not empty because we do have numbers in there that are greater than 2. And D, it's not infinite many solutions, right? Because there's a limitation on it. It can't be numbers less than 2, so it can't be like 0 and -1. So we're either dealing with B or F. Okay, it says x is greater than or equal to 2. So looking at parentheses versus brackets, this does not include 2. Whereas the other one, the brackets, does include 2. So B would be my answer. Answering this now as a solution set in interval notation, remember it should mirror the number line. So traveling from left to right, I see the bracket. I begin at 2. And then where do I go? All the way into infinity. So referring back to the last one, we had negative infinity up until 3, not including 3, right? But now the first time we get something is 2, so that's why you see that 2 first, and we included it, so we used a bracket, and then we went to infinity. So other than an empty set, use interval notation to express the solution set and graph each solution set on a number line. Okay, so same thing. We're going to take this inequality and solve for x. A bit more going on here, right? But nothing changes in the sense that we're solving for x. So I'm going to simplify both sides. I get 18 minus 12x is less than or equal to 6 minus 9x. I'm going to subtract 18 from both sides, giving me negative 12x is less than or equal to negative 12 minus 9x. Almost there. I'm going to add 9x to both sides. I get negative 3x is less than or equal to negative 12. Here's where the difference comes, the only difference comes between solving equations and solving inequalities. You always approach them the exact same way. You simplify both sides. You try to get your variable term to one side, constants on the other. If at this point you have to divide or multiply by a negative, the moment that you do that, so because I said negative 3 divided by negative 3, my sign flips. So finish off the math. Negative 3 divided by negative 3, negative 3x, excuse me, divided by negative 3 would have just left me with x. Negative 12 divided by negative 3 equal, positive 4 equals positive 4. But notice that my sign flipped. And the reason that that happened was because I divided by negative 3. Okay, so x is greater than or equal to 4. So I'm looking for values that are greater than 4. So I'm going to knock out B, knock out D. Looking at A and C, the only difference is one has parentheses and one has brackets. Because this inequality reads x is greater than or equal to, I know that that's going to be brackets. So my answer would be C. The solution set will mirror that number line. So I have brackets 4 and then to infinity. Now you can answer the solution set first and then go to the number line. I just have found that if students struggle with the interval notation for the solution set, that many times drawing the number line will be helpful. And if you find that you need more practice with inequalities, you can go to section 1.7 in your study plan and it can help you there. Okay, so let's look at this piecewise problem. It tells us that our favorite dog groomer charges according to our dog's weight. If the dog is 15 pounds and under, the charge is $35. If the dog is between 15 and 40 pounds, including 40 pounds, the charge is $40. And then if the dog is over 40 pounds, the charge is $40 plus an additional $2 for each pound. So what would be the charge for a 10-pound dog? Well, if my dog is 15 pounds and under, the charge is $35. So that would fit into the $35 range. What if my dog was 20 pounds? Okay, well, if my dog is between 15 and 40 pounds, then it's a $40 charge. Okay, what is the charge for a 40-pound dog? Well, that same range between 15 and 40 pounds includes the 40 pounds. So that would be $40 still. And then it says, what is the charge for a 52-pound dog? Okay, so now I've exceeded 40 pounds, or my dog's weight has exceeded 40 pounds. So if my dog's over 40 pounds, the charge is $40 plus an additional $2 for each pound. So I'm going to pay $40 plus an additional $2 per pound. Okay, my dog is 52 pounds. This would be 104. So I'd end up paying $144. So my input would be how much my dog weighs. Okay, so X will be the weight of the dog. And then my output, my Y, will be the cost to groom them. Okay, so f of X equals, and this is not just going to be one set function, right? Because it changes depending on what range X falls into. So we said, okay, well, in this first scenario, the first one right here, the charge, my output, is a fixed $35, right? But that's only if the dog's weight, X, is 15 pounds and under. So it would have to be between 0 and 15. So it can be equal to 15. That's why I put X is less than or equal to 15. But then your dog would obviously have to be greater than 0 pounds, right? Otherwise, you wouldn't have a dog. So my output is a fixed 35 if X is between 0 and 15, including 15. Okay, so now let's look at the second one. If my dog is between 15 and 40 pounds, including 40, then it's a fixed $40 charge. But this is only if we're between 15 and 40. And then the last one, and actually I'm going to go back and adjust this because it says, what is the charge for a 52-pound dog? It's not per pound. It's worded that way. I feel like it is because it says plus an additional $2 for each pound. But it's for each pound over 40. So we have to change this a little bit. So $40 plus 2 times 52 minus 40. So that would give me 2 times 12, which is 24, plus 40 would be 64. So a lot less. I was looking at the graph, and if we don't match it, then it might confuse you. So that's just worded a little bit funny. But if they said $2 for each pound over 40 pounds. Okay, so we have an output of 35 if X is between 0 up, including 15. 40 is my output if 15 is between, if X is between 15 and 40, including 40. Or the last output is 40 plus 2 times whatever the weight of the dog is minus 40. And that's if X is greater than 40. So do you see that only this last one right here, the 40 plus 2 times X minus 40, is dependent, well, I don't want to say it's dependent upon X because all of them are dependent upon X, but the output actually involves a calculation with X in the mix. The other two, they're constant, right? So looking at this now, that's why we see this constant right here. 0 to 15, including 15, we're up here at 35. And then starting from 15, but not including 15 on this line, or this portion of the graph, to 40, we're at $40. But then after that, you see it increasing because now we're going to calculate X into the mix. So the greater that X is, the greater that the output, the Y, will be. Where from here to here, these two, it was constant during those intervals. Okay? So keep this in mind. But this is a perfect example of a piecewise because our function is literally in pieces, right? We're saying, well, this piece goes according to this function, but then this piece travels according to this function. So that's what we're talking about when we're referring to piecewise functions. So here we go. They want us to evaluate the piecewise function at the given values of the independent variable. So all this is saying is plug it in, right? Remember that this value right here, that's my X, right? That's my input. So I'm going to have to determine, well, does it go into this function or does it go into this function? And that will be dependent on the criteria, right? If it's less than 0 or if it's more than or equal to 0. So I'm going to show you this and then we're going to practice putting it in our calculator. F of -3 is -3 in this category or this category. -3 is less than 0. So F of -3 would be 5 times -3 plus 4. We get -11. Okay, F of, that's A, F of 0. Okay, that would fit into this category because if X is greater than or equal to 0, then it follows this portion of the function. So 2 times 0 plus 7. So F of 0 equals 7. And then C, F of 1. And again, that would meet this criteria, so we're going to follow this portion. 2 times 1 plus 7, f of 1 equals 9. So two different functions, well, I say different functions, but two different expressions that we're plugging things into depending upon what criteria it meets. Is it less than 0 or is it greater than or equal to 0? So make sure you pay attention to that. But depending on what your x is, then we determine, oh, that would be at this part of the function. And we won't quite get the calculator out just yet, but I want to show you what format you'll be plugging into your calculator. So if I was to plug this into the calculator, I would go where I usually would enter my function in. But remember, now we have more than one function going on in this one function, right? So more than one expression being followed. I would write 5x plus 4 in parentheses. And then afterwards in parentheses, I would give that second part. You don't put if, you just put x is less than 0. And then in the bottom one, I would put 2x plus 7 in parentheses. And then in a second set of parentheses, x is greater than or equal to 0. And the calculator understands that you're saying, okay, follow this 5x plus 4 if x is less than 0. But if x is greater than or equal to 0, then follow the 2x plus 7. We'll see that here in a little bit. So in this one, they tell us to evaluate the piecewise function at the given values of the independent variables. So same thing. They're saying plug it in, plug it in. So this is telling us that we're going to follow x squared minus 16 over x minus 4 if x is not 4. And then our output is just plain old 5 if x is equal to 4. So for h of 3, my question would be, which criteria does it match? It matches this first one, right? 3 is not equivalent to 4, so I'm going to plug it into the top function. So h of 3 equals 5. Then h of 0, again, which criteria does it meet? It meets that top one. 0 is not equivalent to 4. So h of 0 equals 4. And then c, h of 4, h of 4, well, which criteria does it meet? It meets the second one, right? 4 is equivalent to 4. And h of 4, there's nothing to plug in and calculate. It's just a constant output of 5. So that's where we got this from here, right there. Oh, let's go back so I can show you real quick what you would have entered into your calculator. So if I was entering this into my calculator, we're about to use the calculator on the next one. That's what just reminded me. So I would put x squared minus 16 over x minus 4, all in parentheses. And then in the second set of parentheses, I would put x does not equal 4. And the calculator will understand, okay, we're going to apply that first function when x does not equal 4. And in the second set of, in the second line, I would put 5 in a set of parentheses. And then in the second set of parentheses, x equals 4. And again, that communicates to my calculator, okay, my output will be a constant of 5 when x is at 4, or when x equals 4. Okay. Says the domain of the piecewise function is negative infinity to infinity. They want us to graph the function and then use the graph to determine the function's range. So let's do that first thing. of A, graph the function. Let's determine what we would put in our calculator first. So I'm going to put negative 3x. And then in my second set of parentheses, when x is less than 0, then on my second row, I'll put positive 3x. And then in my second set of parentheses on that second row, when x is greater than or equal to 0. I find that sometimes it helps for me to write that down separately instead of just trying to go directly from here to my calculator. Just less thought. Okay, so from the main menu, we pressed 5 to go into the graphing function. In my first row, I'm going to do open parentheses, negative 3x. So there I'm telling it what function to follow. And now in my second set of parentheses, I'm going to tell it what is the criteria. So when x is less than 0. To get those inequality signs, we'll go to our catalog. So Shift 4. You can scroll down, but you'll be scrolling for quite a while if you're at the very beginning of the catalog. So if you press the decimal button, it takes you down to the pi symbol, and then go ahead and scroll down and you'll start seeing the inequalities. Now be careful because this is one that you'll come across first. That is actually the symbol for angle. And if you don't see it grouped with the rest of the inequalities, then you're not in the right spot. There we go. Once you see the equal sign, then you start going into the inequalities. So we said when x is less than, there's my less than symbol, 0, close my parentheses off, execute, so it takes me to the next row. Again, in parentheses, this time we're saying, okay, we want you to follow 3x. And then open up a second set of parentheses when x is greater than or equal to. So again, Shift 4 to get to your catalog. Scroll down. There we go, greater than or equal to 0. If you get an error when you press enter here and you try to actually graph it, I would check the signs. A lot of times people will accidentally put x is greater than 0 and x is greater than or equal to. So then the calculator gets confused and it's like, I don't know which function to use. Execute it. And then we'll press F6 to draw it. And we get our graph. So it very clearly shows you that this is the graph of B. And then it wants us to determine what's the function's range. Well, remember, range is all of our y values. So we don't get a y value until we get to 0, 0, right? That's the first time that we hit a y value. And then from there on up, we have y values. So my range would be 0, including, that's why I use the brackets, to infinity. Okay, it gives us the domain of this piecewise function as negative infinity to infinity, and then it wants us to graph the function. So I'm going to go ahead and determine what I will be entering in first. The first part of my function is a constant output of 2 if x is less than or equal to 5. And then the second part of my function is also a constant output, but of negative 2 if x is greater than 5. So we enter it into the calculator, open parentheses 2, close parentheses, and then in our second set of parentheses, we'll put x is less than or equal to, Shift 4 to get to the catalog. Five, close parentheses. And then negative 2. Oops, forgot my 2. And then in our second set of parentheses on the second line, x is greater than 5. Okay, so let's see how that looks. So we see the calculator trying to connect these two lines. Be careful of that. That's not a true representation of the graph. That's just the calculator trying to connect it. So we see y equals positive 2 line right here in this portion of the function. And then after x equals 5, so after x reaches 5, then we see that line now be y equals -2. Okay, so we can mark out A, we can mark out B. C and D both look like let me bring the calculator back up. Both look like what we see in the calculator. So what is the difference here? The only difference is what's happening at 5. This y equals 2 line on C does not include the value of 5. That's why we see an open circle. But the y equals -2 line has the closed circle on 5. Whereas on D, the y equals 2 line up here does include when x is 5. So that's what we're comparing right here. So let's look back about our function. When x is 5, it should be 2. Our output should be 2. Our answer would be D. All right, the domain of the piecewise function is -infinity to infinity. They want us to graph the function, and then they want us to determine the function's range. Again, first going to determine what am I entering into my calculator. For the first one, I would enter in -4x. And then that's if x is less than or equal to 0. On my second part of my function, it will be a constant output of -5 if x is greater than 0. So let's put that in the calculator. So -4x if x is less than or equal to 0, and then -5 if x is greater than 0. Okay, let's go ahead and draw it out. Okay, so notice that everything that's less than 0, you see it traveling downward. And look at the function, -4x. So we should see a downward slope from going from left to right. But then after 0, you see that you have a y equals -5 line. It's constant -5. Okay, let's first eliminate the graphs that are like completely not going to be it. So A, no, it's flipped around some. B, nope, not seeing it. C looks like it could be it. Oh, and then D knocks it out too. So I thought that they were going to have something like the last one where it could be a possibility of which one, included the 0. But here we see that, okay, everything before 0, including 0, follows -4x. But then starting after 0, you can't see it too well, but it's actually an open circle. So not including 0, but anything greater than 0 follows the y equals -5. So C would be my answer. Okay, let's talk about range real quick. So my range will be a bit of a mix of what we've seen in the previous problems. So traveling down from the bottom to the top, the first time that I hit a y is -5, right? I hit -5, but it's just that one value. It's not like from -5 all the way up, right? We have a huge gap with no y's right here. So I'm going to use set notation for that -5 because I can list the values in that portion of my function for my y's. But then we're going to use union because then we have a range of y's that we can use set interval notation for. So -5 union 0, including it, right? We see that the circle's filled in, so it's including 0 for that y, and then it just keeps going up and up and up, so to infinity. That is a tricky answer because it literally includes like everything, right? The bracket, the parentheses, the set notation, so hopefully that makes sense to you.